All right, so question 26, it walks you through, and we'll get back to the actual question in a moment, but it says you've got basically two parks, park A and B at those red spots, right, those red points, and then you've got this kind of rectangular city limit set of boundaries, and they want you to create a third park so that it is farthest as possible from A and B, yet still the same distance from A as it is from B. Does that kind of make sense? Okay. Here's the idea. If we were to put these three parks together so that maybe Park C is equidistant from B in A, but minimize the distance that the Park C is from A and B, hopefully you would realize that that should be at the midpoint, right? If I put... see if I can get this thing working. All right, so if we wanted to find the place to put Park C, would be maybe still not working. All right, so if I wanted to put C so that it was, equidistant from A and B, but minimized the distance that it was from A and the distance it was from B, I would put it kind of at the midpoint of the segment connecting them, right? So maybe at that point right there, okay? But what they say is maximize the distance between A and B. So what has to happen is that we need to move away from A and B, right? So basically I need to move away from it on that line right there, okay? Because what we want to do is basically create a series of isosceles triangles, and that segment there would be congruent to that segment there, right? But there is a isosceles triangle that is perhaps maybe the biggest, okay, where those blue segments are bigger than these red ones, right? And that blue segment is equal to that blue segment. So we got to find the best place to put our park up here. So they walk you through these steps. These steps are not terrible, and a lot of you said I got partial credit on this, which that's great. Okay, but I want to talk about why maybe the hang-up was on getting full credit. So all it does is, first question says, explain the process that you're going to go through, and we're going to find the perpendicular bisector of AB, and then find out where that intersects city limits farthest from A and B. So in this case, it's my option A. Okay, construct the perpendicular bisector of AB, find where it intersects the city limits farthest away from AB. So that's kind of a description of what I just showed you with those markings. And this says identify the coordinates of Park A and Park B. So Park A's coordinates look like they're at 4, 2. B's look like they're at 16, 4. Stuff that, obviously should not have been something that we missed there, okay? Next says find the coordinates of the midpoint, okay? Well, we know the midpoint is the average of the x's. So 4 plus 16 is 20. Average that gets 10, right? And then do the same thing for the y values, so that should give me 3. So 10, 3 should be the midpoint. So that's where I would put the Park C if I want it to be equidistant from A and B and minimize the distance it is from A and B, okay? It then says the slope of AB. The slope of AB, okay, I'm going to use y2 minus y1 or x2 minus x1. So 2 minus 4 gives me negative 2 up top. And then 4 minus 16 gives me negative 12 on the bottom, right? Okay. Now before I hit enter, it's probably going to count that wrong because I didn't simplify it, right? So what's negative 2 divided by negative 12? What's that simplify to? 1/6. So that's how I'm going to type that in. That's my slope. Okay. Now, anything that is perpendicular to AB is then going to have a slope of what? Negative 6. Okay. What I want you guys to realize is that, these questions are building you up to, step by step, prompting you what you need to do to come up to a conclusion, right? All in like an end of course exam or in an algebra 2 or advanced math or calculus class or ACT, they're not going to build you up with these individual parts A, B, C, D. They're going to say, here's the situation. You do A, B, C, D without any prompting and get the solution. Okay, so those are here, and it's nice for us. These are things we always want to commit to memory and be able to do this process over and over again on our own. Okay, now we just got to click on this click to enlarge graph tool, and it asks us to graph it. Now here's the thing, and this is one of the reasons why I'm trying to get you guys to use GeoGebra, is because when you're on the intercourse exam and they ask you to graph something, you have never used that tool that they're asking you to graph. It's one of the reasons we used Pearson, because a long time ago when we started with MathXL, the information that we were told was that the people that wrote Pearson, the people that write MathXL, are the same exact group of people that write the end-of-course exams. Now, whether that's true or not anymore, I'm not 100% sure. I think it is. But the idea was get used to this format so that when you get the end-of-course exam, you're used to it, right? So you don't know what tool they're going to use to help you graph this and how that's going to work. But trying to maybe learn GeoGebra. Maybe we use Desmos a little bit later on. It's a different calculator. But learning different types of calculators might provide you a little bit of insight on the end-of-course exam when something completely new comes about and you have to operate within it. Does that make sense? Okay. So we have to operate within this. And it walked us through steps. It said find basically the midpoint of this line and then use the perpendicular slope to create the line. Well, I've looked through here, and I'm looking for a point tool, and none of these options that I have provide me a point, okay? So my next thought is, okay, well, if I have a line tool, the only way that I can dictate a line is through the use of 2 points, right? I'll just make sure that one of the points that I dictate is going to be that midpoint. So the midpoint was at 10.3, so I'm going to put a point at 10.3. And now it says you had a slope of -6, right? So -6 slope means down 6 into the right 1. And here's where your logic and your understanding of math has to take place. If I'm at a y value of 3 and I go down 6, it puts me off the graph, doesn't it? Okay? But I would go 1 then to the right, correct? Okay? So I'm looking for a line that has kind of an orientation like that, but I want to be exact. So instead of going down 6 to the left, or sorry, down 6 and to the right 1, how can I use the same slope but then move up? Because I can go up 6 units to stay on my grid, right? Then I go left 1, okay? So up 6, left 1 is the same slope as down 6, right 1, okay? So I'm going to go up 6. So y value is at 3. I'm going to go up 6 to 9, okay? And then left 1. And then I put my other dot. And that then, before I hit save, I'll make sure that looks like it's the perpendicular bisector. It looks like that to me. Hit save, check my answer. It puts it in there for me, tells me I'm right, all that good stuff. Okay, now here's where, and I actually, working through with the last class, I messed this up. I couldn't really understand their wording, okay? It says you've got 2 options for the part. What they want you to do, they said, write down the 2 options so that you're not on city limits, so you're not on the blue horizontal line up here of y = 11. But you're close to it, in regards to integer ordered pairs, okay? So would you guys agree that this spot, kind of like right there, is really what they're talking about? Does that make sense? And they say find 2 potential ordered pairs that would satisfy this condition. We don't want to be on the blue line, so it forces me to come down to that line to keep integer ordered pairs. And they want whole numbers, they want integers, so I can't put it there. That would be really where they want it, right? Okay, if I'm not, and actually the best place that they would want it would be like right there. So we're not on city limits, but we're as close to them as possible, right? What they're asking you to do is come down here to here, find that ordered pair right there, which looks like it's 8, 10. And then that ordered pair right there to the right of that red dot, and that's going to be, what, 9, 10? Those were the 2 ordered pairs that they were looking for, okay? We do actually have the algebra, and just because of time's sake right now, I'm not going to go through it, but we actually have the algebra to find that right there. And it's not too hard. We can find the equation of the blue line, which we worked on Friday, and then just set that equal to the equation of that horizontal line, y = 11, and you can find the intersection pretty easily, okay? That's what they're getting at. I think the wording to find those 2 points, 810 and 910, is terribly bad. Okay, it's a very poor choice of wording on their part. So that's what they're getting. So hopefully you didn't miss this because of not knowing what to do, just missed it because of, again, the instructions were bad. On